Hello everybody. We're going to solve some polynomial inequalities today, and I've got this example that is a factored quartic. That would be an x to the fourth if I multiplied it out. What we want to find out is we want to find all values of x that make this less than or equal to 0. And so I've got this written out here. I'm looking for where the graph is below the x-axis. And so what I need to look at is it less than or equal to or just less than. And since I've got this bar here that or equal to, I'm also going to be including where it equals to 0 in my solution. So here's what you're going to do. The first thing you're going to do is you're going to set each one of these factors equal to 0. And we are going to find some test points. What this is going to be is all of these numbers are where it actually equals 0. So x equals 5, x equals 1, and x equals negative 3. So I've found 3 places where this graph has roots, where the graph touches the x-axis. Now, if you could graph this thing with your knowledge of polynomials, it'd be a lot easier, but I'm going to assume that you don't remember how to do that, and I'm going to show you how to do it analytically. So you find all of your zeros. And then I'm going to make this little test bar, and this bar is just going to be like an x-axis. And on this x-axis, I'm going to put all of those zeros in order from left to right. Let's see, I've got a 0 at negative 3, I've got a 0 at 1, and I've got a 0 out here at 5. And so what you have are some intervals. Way out here to the left is negative infinity, and way out here to the right is positive infinity. And I have 4 intervals. I've got the interval from negative infinity to negative 3, from negative 3 to 1, from 1 to 5, and from 5 to infinity. And what I'm going to do is I'm going to pick numbers in those intervals, and I'm going to plug those numbers into this polynomial, and I'm going to ask myself, is that positive or negative? So, because I'm trying to figure out where the graph is below the x-axis. So let's try a number that's in the interval from negative infinity to negative 3, like negative 4. If we plug negative 4 in for x, let's see what happens. Okay, negative 4 minus 5 is negative 9. Negative 9 squared is a positive number. Negative 4 minus 1 is a negative number. Negative 4 plus 3 is a negative number. What's a positive times a negative times a negative? Well, that is a positive number. That means that the polynomial is above the x-axis in that interval. If you can try any other number you want, but they would all work out to be like this, to be a positive number. That means our polynomial is above the x-axis. If we remembered a little bit about end behavior, you know, we had an x to the fourth, that's an up, we would know it would have to be above the x-axis here, but we'll make connections later. Now let's try a number in the interval from negative 3 to 1. I'm going to try 0 because that's an easy one to pick in that interval. So let's plug 0 into our x. 0 minus 5 is negative 5. Squared is positive. 0 minus 1 is negative. 0 plus 3, well, that's positive. And if I multiply those numbers together, I get a negative. That means our polynomial is below the x-axis. I wonder why that is. Look at this x plus 3. The graph must have just crossed through there, and since it was above, it crossed through there. Now it's below. It's all coming together. Wow. Okay, let's try some more. Let's try an interval from 1 to 5. How about 3? That's a number between 1 and 5. Okay, if we plug in 3 for x, 3 minus 5 is negative 2. Squared is positive. 3 minus 1, positive. 3 plus 3, positive. So on this side of 1, it is now above the x-axis. And the last thing I'm going to try is something between 5 and infinity, like 7. 7 minus 5 is 2, squared is positive. 7 minus 1, positive. 7 plus 3, positive. It didn't change sign there. I wonder why the graph didn't cross the x-axis at 5. That's a bounce. Wow. Okay, so let's answer our question. We are going to state that this graph is below the x-axis or equal to on the following intervals. Let me get to my little pointer here. Go up just a little bit more so I can see. All right, so here is going to be my answer. From negative infinity to negative 3, my polynomial was positive. That means above the x-axis. Less than or equal to 0 means below. That is not in that interval. However, from negative 3 all the way up to 1 with brackets, because it's or equal to, that's one of my solutions. This is an interval where that graph is below the x-axis. And that was the only one where I got a negative value. All of these other ones, it was above the x-axis. This is my solution to where that polynomial is less than or equal to 0. Let's see another one. Oh man, one that's not factored. Okay, so I guess we've got a polynomial here, not factored. The first thing we're going to do is factor it. So let's take out an x. It is not factored yet, but this is a perfect square trinomial. My x is being weird. Okay, we're erasing that because that's just ridiculous. Eraser, big eraser for big ridiculousness. La, 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 la. Choo, 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 choo. Lost my x with my eraser. All right, so let's try this again. That factors into x minus 1 squared. And we want to find out when this cubic is below the x-axis or equal to it. So we're going to go take a little number line. And underneath this number line, we are going to put all of the zeros. The zeros are at 0 and 1. That's it. Out here is negative infinity. Way out here is positive infinity. So what we're going to do is we're going to ask our polynomial if you're positive or negative. And what that means is, polynomial, are you above the x-axis or below it? And here's how we do that. Pick any number from negative infinity to 0. Let's try negative 4. Any of them. Let's plug negative 4 into our factors. If we plug negative 4 in for x, I get a negative. And then if I plug negative 4 in for x here, negative 4 minus 1 is negative 5, but squared is a positive. Negative times a positive is a negative. The polynomial is below the x-axis. Does that mesh with the end behavior for a positive x cubed, that it's down to the left? All right, let's try another one. Now let's try a number between 0 and 1, like 1/2. Okay, if I plug in 1/2 for x, I'm going to get a positive. Then, if I plug 1/2 in for x, 1/2 minus 1 is negative 1/2, but negative squared is a positive. And I get a positive in the interval from 0 to 1. And then for the next interval from 1 to infinity, I'm going to try 10. Any of those numbers from 1 to infinity. Plug in 10 for x, I'm going to get a positive times a positive, and that's also positive. So where is this polynomial? Less than or equal to 0? Anywhere its y values are negative, and that's on the interval from negative infinity to 0. So my solution to this is negative infinity to 0. We never put brackets on infinity because we can't actually get there. But I will put brackets on the 0 because of the or equal to thing. Okay, and the last thing we're going to talk about is, what if it's this great big x to the 4th thingy, and you're like, I'm not factoring that, bro. Well, one thing you can do is you can take, and I have it written out here, move everything to the left side of the graph and then pull out your calculator. Of course, this won't help you if it's a non-calculated part, but it could be a calculated part. Find your zeros, and then you can sketch a graph of the function, and you can figure out where the graph, and this one is greater than 0, so you would figure out where it's above the x-axis. Anyway, I really hope you guys work well for your sub tomorrow. I want to hear a good report, and I want you to have a great weekend. There'll be another video put up this weekend for Monday's work. Deuces.